This question is telling a photon emitted during de-excitation of electron from state N to the first excited state in a hydrogen atom irradiates a metallic cathode of work function 2 electron volt in a photocell with stopping potential of 0.55 volt. Obtain value of quantum number and of that particular state. Try to represent this as a diagram. This is the level N. So energy will be En. It's de-exciting to first excited state means level 2. Ground state is level 1. First excited level is n equal to 2. This is a common mistake. Normally people take first excited level means n equal to 1. Ground level is n equal to 1. First excited level is n equal to 2. So the energy of first excited level you can calculate using the general formula for the energy of electron in hydrogen atom. This shows the de-excitation of the electron, releasing a photon, energy h nu. That is hitting on a metal, releasing one electron. The electron is stopped by 0.55 volt stopping potential. You can find the energy of the nth orbit using minus 13.6 electron volt by n square. For level 2, E2, so minus 13.6 by 4 be minus 3.4 electron volt. We have kinetic energy is EV0. So the V0 is 0.55. Maximum kinetic energy of the electron emitted will be 0.55 electron volt. The work function is given already as 2 electron volt. If you see the first process, according to Bohr model of hydrogen atom, the third postulate, the energy difference, initial minus final, will be frequency into h, Planck's constant, the energy of the photon. Here initial level is En, the final level is E2. So En minus E2 equal to h nu. We know the E2 value calculated as minus 3.4. If we substitute that here, En minus 3.4 electron volt, that become En plus 3.4 electron volt equal to the energy of the photon. This is equation number 1. Then the second process is photoelectric emission. So using Einstein's photoelectric equation, we already know Ke max. That should be equal to h nu, energy of the incident light minus the work function. If you use equation 1 and equation 2, the Ke max is already 0.55 electron volt. H nu we already calculated as En plus 3.4 electron volt. Work function is again 2 electron volt. So from this you can calculate the value of En, transpose the terms and get minus 0.85 electron volt on calculation. After getting En, again you can use this particular formula. En is equal to minus 13.6 electron volt by n square. So n square will be the En value in the other side. Taking square root, you can find n equal to 4. Or if already you learn the energy levels of hydrogen, like if you learn energy level of 1, the ground level is minus 13.6 electron volt. Then level 2, the energy is minus 3.4 electron volt. Like at least the 4 levels. First 4 levels, if you learn, the process will be easy. Even it will be helping you a lot in the numerical questions related to these energy levels. It's 1.51 electron volt. And there are so many levels, at least the first 4 if you learn, that's good. It's equal to minus 0.85 electron volt. If you know this, the last part calculation, you can avoid. After getting directly En equal to minus 0.85, you can directly write n equal to 4.